Dear students, I welcome you all to this new video lesson in the e-learning series for class 11th Computer Science. In this video lesson, we will be discussing the chapter Sorting Algorithms. There are various type of algorithms that are used for sorting a list of elements, but in your syllabus, only bubble sort and insertion sort are given. So we will focus only on these two algorithms. In the beginning, we will be discussing the basics of sorting, and then we will cover bubble sort and insertion sort one by one, and at the end we will have the Python programs on these two sortings. We will discuss the working of bubble sort and insertion sort, and we will also see some examples through which the theoretical approach of these sorting algorithms becomes clear to you. So let's get started. Sorting in computer means arranging the elements in a specific order. This order can be either ascending or descending. There are many algorithms that can be applied to sort a group of elements. Some of these sorting algorithms are selection sort, bubble sort, insertion sort, heap sort, quick sort, and there are many more. So let's start with the first one, that is bubble sort. Bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements and swaps them if they are in the wrong order. So you will be given a list of items having some elements, and you have to sort them either in ascending or descending order. So if you apply the approach of bubble sort, then you have to compare adjacent elements and swap them if they are not in the correct order, and you should move on in the array. The pass through the list is repeated until the list is sorted. So you have to go through the list again and again until you get the sorted list. The algorithm, which is a comparison sort, is named for the way the smaller or the larger elements bubble to the top of the list. You will see in the example that a particular element bubbles through the list and moves to the top. You have seen the bubbles in water. It starts from the bottom and moves to the top. That's why this sorting is named bubble sort. In this bubble sort algorithm, after each pass, one element is placed at its correct position in the list, and we need not compare that element in the next pass. So when you move through the list once, one element will be placed at its correct position. In the second pass, second element will be placed in its exact position. So the number of iterations keeps on decreasing after each pass. Okay, so this was the working of bubble sort. Let us see this example to understand the bubble sort. You have given this list. This is the list of elements 3, 12, 7, 10, minus 2. So you keep on comparing the adjacent elements and swap them if they are in wrong order. So 3 and 12 is compared. 3 is less than 12, so nothing changes. 12 and 7 are compared. 12 is greater than 7, so 12 is swapped with 7. Positions are changed. Then 12 is again compared with 10, so again swapping. 12 comes to this place. Again 12 and minus 2 are compared and you get 12 at the top. So this element 12 bubbles to the top of the list. That's why it is called bubble sort. So this is the first pass. You have gone through the list of elements once. So at the end of first pass, one element, this is 12, is placed at its correct position. Now you will not compare this 12. So you will be comparing only these 1, 2, 3, 4 elements only. Okay. So in the second pass, 3 and 7 are compared, no change required. 7 and 10 are compared, no change required. 10 and minus 2 are compared. 10 moves to the last. Now 10 is placed at its correct position at pass number 2. So at pass number 2, 2 elements are placed correctly. Now at the third pass, 3, 7 compared, no change required. 7 and minus 2 compared, changed, swapped. Now 7 is at its correct position. So at the end of third pass, we have 3 elements that are placed correctly. Now the fourth pass, 3 and minus 2 are compared and they are swapped. So this is the final order of the elements. So you are having 5 elements and it took 4 pass to sort the array or to sort the list of 5 elements. Okay, so 4 times you traverse through the list, comparing the adjacent elements and swapping them if needed. And the most important point to remember is after each pass, one element is placed automatically at its exact position in the list. Okay, so let's have another example. With the help of animation, we will try to understand this bubble sort. Please pay attention to this bubble sort example. 6 and 5 compared, 5 swapped. 6 and 3 compared, swapped. 6 and 1 compared, swapped. 6 and 8 compared, no swapping. 8 and 7 compared, again swapped. 8 and 2 compared, again swapped. And at the end, 8 is compared with 4 and swapping is taken place. Now this element 8 is at its exact position. Now this will be freezed. Now 5 and 3 will be compared, swapped. This is second pass. 5 and 1 compared, swapped. 5 and 6 compared, no swapping required. 6 and 7 compared, no swapping. 7 and 2 compared, swapped. Swapping means changing the place. 7 and 4 compared, swapped. Now after second pass, 7 is also at its exact position. Now again 3 and 1 compared, swapped. 3 and 5 compared, no swapping. 5 and 6, no swapping. 6 and 2, yes, swapped. 6 and 4, yes, change of place. Now we have 3 elements have been placed at their correct position. Now 1 and 3 compared, no swapping. 3, 5, no swapping. 5, 2, yes, swapping. 5, 4, swapped. And 5 is now at its correct position. Now we are left with 4 elements. 1 and 3 compared, no swapping. 3 and 2 compared, swapping. And 3 and 4 compared, no swapping. Now 1 and 2 compared, no swapping. 2, 3 compared, no swapping. 1 and 2 compared, no swapping. So all the elements are sorted. Okay, after this you get the sorted list of elements. Okay, so this was the example. Now let us see the algorithm of bubble sort. Here A is a linear array, temp is the temporary variable that is used for interchanging the positions. So first you will input the array, then you will initialize I with 0, that you are moving through the list. So the initial index of a list is 0 and you will go up to the last. Okay, and you will repeat the step number 4 again and again. What you will do is you will compare the element j with j plus 1. That means two adjacent elements will be compared, and if the order is not correct, you will swap it. Okay, how to swap it? Take a third variable and you can swap it. Please go through this algorithm and you will understand the logic that is behind this bubble sort algorithm. Here the basic idea is to compare two adjacent elements and change them if they are not in the correct order. So the first loop will move through the list and the second loop will check the comparison part. The adjacent elements will be compared. So at the end you will print the sorted list or sorted array A. Now let us see what are the number of operations that are taking place in this algorithm. So it will decide its complexity. The two operations that take place in bubble sort are comparison and swapping. First consider the comparison operation. For the first iteration of the outer loop, n-1 comparisons take place. For the second iteration of the outer loop, we only require n-2 operations. Why? Because one element has already been placed at its correct position. Similarly, when you go third time, when you traverse the list third time, you will require n-3 comparisons. Okay, so on you will move. So the total number of comparisons will be n-1 in the first go plus n-2 plus n-3 dot plus 2 plus last. At the last go you will have just one comparison to make. So this will give us n into n-1 by 2. So this is total number of comparisons are of the order n square. Okay, now let us see the second operation, that is swapping. The number of swapping will vary depending upon the elements in the sequence. In the best case, where all the elements are already sorted, no swapping will take place because all the elements are at their correct position. So you will not swap any element. So total number of operations will be those that are for comparisons, because comparisons will be there. If the elements are already sorted, then also the comparisons will be there, but swapping will not be there. So the order will be of n square. In the worst case, when all the elements are in reverse order, suppose you are sorting in ascending order and your list is in descending order, so this is called worst case. So every comparison will result into a swapping. Whenever you compare, you will have to swap. So the total number of operations will be n square comparisons plus n square swappings. So those are of the order of 2n square. Okay, so these are the maximum number of operations that can take place in bubble sort. Now let's move forward and see the next sorting algorithm, that is insertion sort. Insertion sort is a sorting algorithm that builds a sorted list one element at a time from the unsorted list by inserting the element at its correct position in sorted list. So it selects a particular element and inserts it at its exact position or correct position in the list. That's why it is called insertion sort. This sorting starts its working on the basic principle that a list having only a single element is always sorted. It is very simple rule. If you are having just a single element, then it will always be sorted. So, starting from the second element, because the first element you take and you assume it to be sorted because it is only one element. Now, so starting from the second element of the unsorted list, each element will be picked and it will be placed at its correct position by comparing it with the elements on its left hand side. Okay, you pick an element, compare it with all the elements on its left side, and you will get the exact position of that element and insert it at its exact position. This is insertion sort. And at the end, you will get a sorted list of elements. Okay, so this was the approach of insertion sort. Now let us see example. We have a list 9, 7, 6, 15, 17, 5, 10, 11. The first element 9 will be considered as sorted because in insertion sort we take element by element. So first we take 9, it is sorted. Then we take 7 and we compare it with the elements on its left hand side, which is 9. So what will happen? 7 will be swapped with 9. The position will be changed. Next, now this 7 and 9 are properly sorted. Now we take 6. 6 compared with 9, 6 one is smaller, it will be changed. And then 6 compared with 7, it is also smaller. So 6 will move before this 7. Now your sorted list becomes 6, 7 and 9. Now take this 15. It is larger than 9, so it will not move forward. Why? Because if this comparison, the comparison of 9 and 15 is resulting in false, then that means 15 is larger than 9. So the list on the left of 9 will having lesser elements than 9. So you do not have to compare with these elements. So whenever you get the comparison result as false, just stop there because the other elements on its left hand side will be smaller than this value. So 15 will not be swapped. Again we go to 17. 17 compared with 15. 17 is larger, so it will not move anywhere. It will not be compared with 9, 7, 6. It will not be compared with these three because it has been compared with 15. Now it is clear that in the left hand side of 15 there will be lesser number. The number lesser than 15. So don't go on this direction. Just compare with 15. If you find it greater than greater than 15, so do not go forward, just be there. Now 5 will be compared with each of the elements and you will find that it is the smallest, so it will move to the first position. Now your list becomes this. Now 10 compared with 17, then compared with 15, then compared with 9. When it is compared with 9, 9 is lesser. So no more comparisons and 10 will be placed at this position. And at the end 11, the comparison, after the comparison it will be placed after 10. And at the end we get the sorted list. So this is the approach of insertion sort. Insertion sort, you take one element at a time and place it at the correct position on its left hand side. So what do? You compare that selected element with all the elements on its left hand side till you find number lesser than greater than your selected number. You move on. As soon as you find the number lesser than you just stop there and insert that selected element at that position. So continuing this approach again and again, you will find the sorted array. Let us see this insertion sort with the animated sorting example. Okay, please pay attention to this animation. select 6 is selected, it is first element, so sorted. Then 5 is selected, compared with 6, positions changed. Now 5 and 6 are sorted, 3 is selected, 3 compared with 6, 3 compared with 5, then 3 is at the beginning. Now 1 is checked, 1 will be compared with 6, 5 and 3. It is least, so it will be at the beginning. 8 compared with 6, exact position. 7 compared with 8, which is position changed, and it is after 6. Then 2 compared with 8, compared with 7, compared with 6, shifting, compared with 2, shifting, compared with 3, shifting, compared with 1, no shifting, so it is after 1. 4 compared with 8, shift, compared with 7, shift, compared with 6, shift, compared with 5, shift, compared with 3, no shift, exact position. So this is the answer. Okay. So now we come to the algorithm of insertion sort. Here you select the first element as sorted, then you repeat the steps 3 to 5 for 2, from the element number 2 to last. You select that element and you move backwards, that means to your left hand side. That's why k is becoming decrementing at each step, k minus 1. So you will compare your element, that is temporary element you have selected, with all the element on the left hand side. You change the position of those elements which are greater than it and shift them to the right side, and after the end of loop you put the temporary element at its correct position. Okay, so this is the algorithm and it is very easy to understand. If you have seen the examples, the 2 examples that we have seen, it will be very easy to understand. Okay, now let us see the number of operations here. Unlike the other sorts, in insertion sort, it passes through the array only once. In the bubble sort, you are passing through the array again and again, but here you pass through the array only once, selecting one element at a time. Here also the 2 operations that take place are comparison and swapping. Let us see the comparison operation. During the first iteration of outer loop, the inner loop, there is only one comparison. During the second iteration, there will be 2 and so on, and the last will be n minus 1 comparison. So the maximum number comparisons will be n minus 1 plus n minus 2, same, 1 plus 2 plus 3 dot dot up to n minus 1. That is the summation of n minus 1 elements. So n into n minus 1 by 2, and it is less than n square. So there can be a maximum of n square comparisons in insertion sort. If we carefully go through the algorithm, we will find that the first comparison or first iteration of outer loop, in the inner loop there is at most one exchange. Okay, when you select the second element, it will be compared with only the first one. That will be the only element on its left side. So there will be maximum one exchange, or it can be less than 1, it can be 0. Then in the second iteration, there can be at the most 2 exchanges. Similarly, during the n minus 1th iteration, there will be at most n minus 1 exchanges. So maximum number of exchanges, again, less than n square. So there can be maximum n square exchange, otherwise less than that. So in the best case, there will be maximum n minus 1 number of comparisons and exchanges. Okay, because the array that is given is already sorted, that is called best case. So there will be n minus 1 comparisons only. And in the worst case, there will be maximum possible number of comparison and exchanges, that will be less than n square. Okay, so this is the complexity of these two algorithms, that is of order n square. Now let us see and compare the applications of these two sortings. These are the only sortings that are given in your syllabus. So bubble sort is one of the simplest and easiest to implement sorting algorithm, although it is not considered an efficient sorting algorithm. Even for smaller datasets, insertion sort has proven to be more efficient than bubble sort. Bubble sort can be the best option for sorting when the data is stored sequentially. Why? Because in bubble sort, what do you do? The approach is to compare the adjacent elements. So if the data is stored sequentially, like in the tape, the audio cassettes, one song is after another, then third, then fourth, all the songs are played sequentially. So and in that type of situation, if your data is there stored sequentially, then bubble sort can be implemented because it compares the adjacent elements and then swapping takes place. Okay. Insertion sort, on the other hand, has been a preferred choice for sorting small data sets. It is easy to implement and at the same time it does not require additional memory. In this, you just pass through the array only once. It can be very fast if the data is almost nearly sorted. Okay, so these are the comparisons of bubble sort and insertion sort. So bubble sort will be useful when the data is stored sequentially, and insertion sort has been proven efficient in smaller data sets. Okay, but there are very advanced sorting algorithms which are faster than these two. Now at the end, let us see the program, the Python program for bubble sort. So in the beginning, you will input the list. It will be the list of elements. You have used eval function, so you will be entering the values inside the brackets, the square brackets. So it will be a list. Then you will calculate the length of the list. Then you will go through the entire list because you have to iterate through that list again and again. So this outer loop will help you in iterating through the loop again and again. Okay, so it is a question of nested loop. In the second loop, that is inner loop, you move from 0, that means you see the beginning points are same, because in each pass you have to start again from the beginning, that is index number 0, but you have to move one step less at each pass. Why? Because at each pass one element is being placed successfully at its correct position. That's why this length minus I minus 1. Length minus 1 because the total length, the length that you calculate and the index value, that is the starting index value is 0 and the last index will be length minus 1. Okay, so that's why this length minus 1. Okay, and at each step there will be one element will be at its exact position, so you will be getting one less comparison at each step, and you will compare the jth element with the j plus 1th element. Okay, this sign is very important. If you are using this greater than sign, this will be in ascending order, and if you use less than sign, it will be in descending order. So if you find this comparison, then you should swap the element j with j plus 1. So this is a single line swapping in Python. In other languages like C and C++, you have to write 3 lines for this swapping to take place. That's why this Python is called faster than other languages. So in Python, you can write just a single line to swap 2 elements. What are the two elements that are to be swapped? The jth element of the list with j plus 1th element of the list. So you swap it, and you again at the end of first pass you print the list, and you again start from the beginning. Again the next pass you again start from the beginning, again compare the adjacent elements. If they are not in the particular order, swap them, and in this manner you move forward and you get the proper sorted list at the end. Clear? So in this program the most important thing is this length minus 1 minus I. If you should read like this: length minus 1. Why? Because the last index will be the actual length minus 1. And why minus I? Because at each iteration of I, one element will be placed at its exact position, so you do not have to compare it again in the second pass. So that's how at each pass the number of comparisons decrease. So that decrease is done with this minus I. So at step number I, there will be I elements that have been placed at their correct position. So that's why length minus 1, that is for the proper indexing, and minus I to indicate that at each step one element is being placed at its correct position. So that's why this length minus I minus 1. Okay. Now the program for insertion sort. Again you enter the list, you calculate the length of list, you move through the list. Here you just move through the list once. Okay. Here you should move from the element number 1 because the basic index, the starting index is 0. So you should start from the second element that will be having index number 1 and you will move through the end. So you will put that element as a key, that means temporary, and you will make a value that is I minus 1. Why? Because you have to compare this element, this LSTI, with the elements that are on the left hand side of this LSTI. So on the left hand side of the elements will be having indexes I minus 1, I minus 2, I minus 3 and so on. So that's why we have a decrementing loop of while. So here you have to initialize for while. The first statement is of initialization. The loop variable is j and the starting value of the loop variable will be I minus 1. Why? Because you have to compare this ith element, that is LSTI, with the elements on its left, and the element on the left hand side of LSTI will be LSTI minus 1. That's why the initial value of j is I minus 1. And now the loop that will compare this LSTI with all the elements on its left, but not all. As soon as you find the element less than this, you will stop. So this is the loop. You should not move ahead of index 0. This is the condition, first condition. You should not cross index 0. Okay, you should not go to my negative indexing. So this is the check for it, that you should not move beyond 0. And you should also not move ahead if you find an element less than your selection. So if you are finding an element less than your selection, that means you have to stop. So if you move in this loop, what do you have to do? You have to shift the elements on the right. You have selected the LSTI element, you select it and you have pasted it in other variable called key, or you can write it as temp. Now if you find the elements on its left greater, what do? Is you just shift those elements that you are finding on the left of LSTI to its right side and keep on decrementing, keep on going left. That is why this is j is I minus 1. Okay, then you decrement it and you will go to the left of I minus 1, the first value, then I minus 2, I minus 3, I minus 4 and so on. You will move up to 0, not beyond 0. And you will also check that the value that you are comparing, that is LSTJ, okay, If it is greater than, then only you should shift that LSTJ plus 1 to LSTJ. That means the values are being shifted. And when you have found the exact position of that selected element, that is LSTI, what you do is you put that particular element at its correct position, and after each pass you print the status of the list, and at the end you get the sorted list. So before coming to the programming part, you must understand the theory, that is the approach of this insertion sort and bubble sort. So in insertion sort, what do? You start from the second element, that is index number 1, and compare it with all the elements on its left, and you go on to the left until either you find the index number 0 or you find an element less than your selected element. So these are the two cases for this inner loop. This one, that should not go beyond 0, and this is that you should stop when you find any element less than your element. So what you should do, if you find proper sorting, what you should do is you should shift the elements that are greater than your selection to the right position, to the position on their right. So J plus 1 will move to J. Okay, because you are moving to the left hand side. So when you move to the left hand side, if you find a particular element higher or greater, you shift that element to its right. That's why this is J plus 1 and this is J, and you keep on going to the left, and after you have either reached this or this, what you should do is you should place your selected value at its correct position. So that's how you get the sorted list. So students, this was all about this chapter. This chapter having only two sorting algorithms, selection, bubble sort and insertion sort. I hope this video is able to clear all your doubts regarding your bubble and insertion sort. If you have any doubts still, you can ask me and I will clear your doubts. Okay, so you should go through these two programs of bubble and insertion sort, and before these programs you must be clear with the theoretical part, and for that I have given two examples for each of the sorting, one theoretical and one with animation. So it will help you to understand the working of this sorting algorithm. Okay, thank you very much.